In this video walkthrough, we are going to learn about functions and identify relationships as functions. We're also going to understand and identify domain and range. So the first activity is you're going to use the decoder key in Google Classroom in the assignment doc to decode the message seen below. When you're ready to check if your message is correct, press play. Pause the video and get started. So our coded message said, let's have fun with functions. First, let's think about what a function is. A function is a relationship between input, which is going to be our variable x, and output, which is going to be our variable y, where for every input, you can only get one output. This is going to be the most important part of what makes a function, that for each input, you can only get one output. Here's a visual. If I were to take my input x, put it into my box here, and do some math to it, as long as only one number comes out, then this would be an example of a function. If I were to take an input x and put it into the box and do some math to it, and two possibilities or more came out, that would be an example of something that is not a function. We can look at some real-life examples to help apply some context and see if this makes sense. So do you think the message above that we decoded represents a function? Why or why not? I would think that it does represent a function because for each emoji, there was only one letter possibility. So I would consider the inputs to be the emojis. I put that into the box, and then my box in this case would be the decoder, and the decoder told me what letter would come out. And so the letters are my output. Imagine if your decoder told you that, for example, for a smiley face, that it could have been either the letter A or the letter M, you wouldn't know which letter to put. But since your decoder told you exactly which letter stood for each emoji stood for, there was only one possibility. That's what makes it a function. We're going to see more examples of seeing if things are functions or not in a minute, but first let's talk about some other function characteristics like domain and range. Domain is the name given to the numbers that can go into the function. The variable that we use for our input is x. One helpful way I like to remember domain is that it has the word in right in it. And so my domain is going to be my inputs. You can even think of it as the list of all inputs or possibilities for x. Now the range is just the name that's given to the numbers that can come out of the function. And the variable used for that is going to be y. So my range is just going to be the list of all outputs or possibilities for y. So let's say our mathematical rule says to multiply every input by 2 to get the output. Do we think this rule would represent a function? Why or why not? So that means I'm going to take some number, I'm going to put it into the box where it says times 2, and then I'm going to get out some other number. Well, let's say my number going in were the number 1. That would mean to take 1, put it in, multiply it by 2. How many answers are there to that question? There's only one. It would be 2. Let's say my next input were the number 2, and I were to put that into the box, multiply by 2. How many answers are there to that question? There's just one. The answer would be 4. So yes, I think it's a function because the input can only have one output. No matter what my number is, if I were to multiply it by 2, there's only going to be one possible answer. So my domain is any numbers that I could take and put into the box and multiply by 2. I could multiply any number in the world. So my inputs in this case would be all real numbers. My outputs would also be all real numbers because it's possible to get out a whole variety of different kinds of numbers. Now you might be thinking, well, if we're going to multiply by 2, then my outputs are always going to be even. That would be true if the numbers that I were putting into the function were just integers, like 1, 2, -5, -7. If you were to take those types of numbers and multiply by 2, then you're always going to get out an even number. But if I were to put in like 0.5 times 2, that would actually get me 1. So in this case, there's really no restrictions. What if we were to go to the gas station and pay $3 per gallon of gasoline? What would be the price that we would expect to pay for 3 gallons? For 3 gallons at $3 per gallon, I would expect to pay $9. For 5 gallons at $3 per gallon, I would expect to pay $15. Do you think this represents a function? Why or why not? Pause the video, write your answer in this space. Press play when you're ready to check your answer. So in this case, I would say yes, I think it's a function, because for every number of gallons that I buy, there's only one possible total price I could pay. So for example, for 3 gallons, any person going to this gas station where it costs $3 per gallon, we're always going to pay $9. It's not like somebody would pay $9 for 3 gallons and someone else would pay $10 for 3 gallons. There's only one total amount of money for each number of gallons. Now in this case, the possible inputs is going to represent my number of gallons. And if I think of all of the possible numbers in the world, there's some that it can't be. I can't buy negative gallons. So I could buy 0 gallons, 1 gallon, 2 gallon, so on and so forth. It's even possible to buy half a gallon, but I'm just kind of establishing my list here. I guess ideally what I'm trying to say is no negatives. So if I wanted to write an inequality to show that my input, which is my x, can be every single number in the world except for negative, I could write it as x is greater than or equal to 0. That means that x can be 0 or more. And my outputs of my function, which is going to be my y, again, I just can't pay negative dollars. But if I bought 0 gallons, it would cost me $0, and it's only going to go up from there. So I might be able to say it as y is greater than or equal to 0. Sometimes we might write our domain and range as inequalities. Other times we might write it as lists. For right now, we're just kind of practicing. What about this situation? You find a lost backpack with the initials MS monogrammed on it. You're trying to find the owner. If the input is the initials and the output is the owner, do you think this would represent a function? Why or why not? Pause the video, come up with your answer, press play when you're ready to check. So in this case, I would say no, it's not a function, because if the initials MS, that could be Matt Smith, that could be Melinda Sam, it could be all different people that have the initials MS. So since my initials could go to more than one person, that would be not a function. Now in this case, if it were a function and I was just talking about inputs and outputs, my inputs are letters, and my outputs are people or names. But again, not a function. So now we're going to put our function knowledge to the test. We're going to decide if something is a function, and if it's a function, we're just going to list the domain and range. If not, that means that one of our inputs had more than one output, and we're going to say which one. So on example 4, my inputs are listed here, 0, 5, and 10. I can see that 10 has one output of 3, 5 has one output of 4, but 0 could have an output of 2 or 5. And so what this is going to mean is no, this is not a function because the input 0 has the numbers 2 and 5 as its outputs. If I were to have a function, here I would just list my domain, which would be all my input numbers, and my range, which would be all my output numbers. Let's try example 6. So on example 6, I'm trying to decide if this is a function. Now, inputs I know are my variable x, and outputs are my variable y. So my first input is 2, and it has an output of 0. My next input is also 2, and it has an output of 1. So what this would mean is, no, this is not a function, because the input of 2 has 2 different outputs of 0 and 1. Again, I don't have a domain and range, but if I did, it would be my x values and my y values. Pause the video to try examples 5 and 7. Press play when you're ready to check your answers. So on example 5, this would be a function, yes, because each of my inputs has only one output. 0 has one output of 0, 1 has one output of 2, 4 has one output of 8, and 6 has one output of 12. My domain is all of the possible numbers that are going in, which are 0, 1, 4, and 6. My range is all the possible numbers that are coming out, which is 0, 2, 8, and 12. On example 7, this one is also a function because each input still only has one output. 3 has one output, it happens to be 1. 6 has one output, it happens to be 2. 9 has one output, it also happens to be 2. And 12 has one output, it also happens to be 1. It's okay for my outputs to repeat as long as each input is only going to one number in the output column. So yes, this is a function. My domain would be my list of my inputs, 3, 6, 9, and 12, and my range is my list of my outputs, which you could list 1, 2, 2, 1, or you could just say the only two numbers you expect to come out of your function are 1 and 2. So on example 8, it says that we're buying concert tickets that cost $15 each with a one-time service fee of $10. We can buy up to 6 tickets. So we're going to use this fact later that we can buy up to 6 tickets. We're going to write a rule for the amount of money that we can spend, y, as a function of the number of tickets, which is x that we buy. So in slope-intercept form, I know that my total amount of money, which is y, is going to equal 15 times each ticket, which is x, because I don't know what that is, plus my one-time service fee of $10. So the domain of my function is all of the possible numbers of tickets that I can buy. And so the possible numbers of tickets that I could buy would be 1, 2, 3, 4, 5, 6. And the reason I have to stop is because it told me that I can buy up to 6 tickets. Now you might be thinking, what about 0 tickets? I totally agree that you could buy 0 tickets, but if I were to change x to 0 in my function, 15 times 0 would be 0, and 0 plus 10 would be 10. It wouldn't make sense that I would pay $10 if I wasn't buying any tickets, so this function that I've written only makes sense for the numbers 1 through 6. So I'm going to list these here, and I'm going to use this to help me find my range, which is going to be the possible amounts of money that I could expect to spend. I can evaluate this for each of my numbers. 15 for one ticket would be $15, plus my fee would be $25. 2 tickets at $15 each would be $30, plus 10 would be $40. 3 tickets at $15 each would be $45, plus 10 would be $55. So on and so forth. I can keep doing this, noticing that I'm adding 15 every time. And so my range is going to be these amounts of money that I would expect to pay, which would be $25, $40, $55, $70, $85, and $100. That would be my range. Give example 9 a try. Try parts A, B, and C. Pause the video, press play when you're ready to check your answers. So my equation or my function would be y equals 12x plus 5 because it's $12 per lesson and plus my $5 art kit fee. For my domain, since it told me that I could attend up to 5 lessons, I knew I had to stop at 5. Now originally I started with 0, but again, if 12 times 0 is 0 plus 5 equals 5, I probably wouldn't pay for the art kit if I wasn't planning on attending any lessons. So for this function, I said that my domain would be 1, 2, 3, 4, and 5. Then I plugged in each of these numbers to find my range or my y values. So 12 times 1 is 12, plus 5 is 17. 12 times 2 is 24, plus 5 is 29. 12 times 3 is 36, plus 5 is 41. I'm also noticing that every time this is just going up by 12. So for the last two, I just actually added 12 each time.